This is part 3 in a series of videos in which I am trying to boot this MIMI 803 using a floppy disk. If you watched the original series on this machine, you'll know I carried out quite a lot of repairs to it, but I couldn't try booting it because I didn't have a floppy disk. We've since been sent what we believe is a copy of a disk from a MIMI 802, and the gentleman that sent those has just sent me a disk that we believe is the actual boot disk for a MIMI 803. However, I've tried that disk in this machine and it still won't boot, and so the next step really is to start looking at whether we have an issue with the floppy drives on this machine, or possibly a hardware fault in the floppy drive circuit. It's evident that it's working to a certain extent because the machine is responding when it's trying to boot. We're seeing activity on the VCO circuit that's responsible for synchronizing the reading of the disk. So what I've done so far is decompile the code in the MIMI monitor ROM. So that's the code in this ROM here, and what I will be doing now is using the logic analyzer to try to figure out exactly why the machine isn't booting, or at least why it's not reading from the floppy drive. I don't think it's a fault with the floppy drive itself, because it does exactly the same thing with the emulator, but we'll have a look at that in this video as well and see if we're getting the same results. But the first step is to try to figure out exactly how far the floppy drive system is running through the startup. If you're not familiar with the way floppy drives work, it's probably a bit more complex than you might imagine. In order to maximize the capacity on the drive, the rate at which data is stored is fairly tightly controlled, so it maximizes the storage space on the disk surface. But in order to successfully read the data back, it means there has to be some way to synchronize the reading of the data with the data stream that's coming off the disk itself. Bear in mind that varies depending on exactly where the heads are on the cylinder, because of course as you go further out from the center of the disk, the surface speed of the disk is effectively higher. So the way it works on most floppy drive systems is you have a closed loop control system that is partly controlled by the data stream coming from the disk itself. So to give you a very brief explanation, the combined data, that's the raw data coming from the floppy disk, contains both clock and data information, and we are using a read clock, which on this trace, this diagram is the top line, and the read clock is the timing, if you like, for reading data from the drive. And then what we have to do is figure out whether it's running at the right speed or not. And so the data that's coming from the disk itself, that is the transitions in the flux that are being read from the disk, are compared to the phase of the read clock, and then the phase is used to either increase the speed of the clock or decrease the speed of the clock to bring it into sync. All sounds very confusing if you're not used to it, but what we'll do is we'll have a quick look at this working on the logic analyzer. So I'll move the camera so you can see the analyzer screen. So looking at the analyzer screen, you can see I've added two new symbols. One is R clock and one is not RDD. So the R clock is the receive clock and the not RDD is the raw data that's coming in from the floppy drive. The analyzer is set to trigger on the R clock, so every time the R clock goes high, the analyzer will trigger, which means it's effectively going to free run when I arm it, because the R clock is running all the time. That's the signal we were looking at on the scope in the previous video, and the rate of that clock is modified by the incoming data stream. So I'll arm the analyzer. You'll see that immediately we get a capture, and the RDD at the bottom is doing nothing because currently the disk is not running. So I have one of the MIMI 802 disks in the drive at the moment. And what I'll do is press the B key on the MIMI, and that will start the disk spinning, and the system in theory should be trying to read data, and then I'll rearm the analyzer and we'll capture some fresh data. So I'll press the B key now. We've heard the disk start up. I'll arm the analyzer see we've captured an event there and another one. So we're capturing data, but it doesn't look right. You'll see that although the clock is running as it should, the data coming from the disk doesn't look right. We should be getting a transition on every single R clock, but also we'll try it again just to make sure that we're not missing something. So I'll restart and I'll keep arming. You'll see that there's something distinctly wrong with that. So it almost looks like the floppy drive isn't reading data at all. So I'm going to take out that disk. I'm going to swap it with a disk that we believe is an actual MIMI 803 boot disk, and we'll see if we get the same thing appearing on the analyzer. So I was popping the disk in, and now we'll do the same test. I'll start the MIMI reading the disk and then rearm the analyzer. And what we can see now is that we're getting data on every single R clock. Not only are we getting data, but you can see it's maintaining fairly close to the center of the R clock, which is exactly what it's supposed to do, and that is the purpose of the synchronization. So if we look back at the information we have here, we'll see that we're getting a transition on every single R clock event. The only thing is, it seems to be inverted. Now, whether that's just because of the phase it's reading, or there is something actually wrong with this, I'll need to check. But I would have expected it to be in the same phase that we're seeing here, and it's not. It's completely out of phase. So I need to check that to see why it's doing that, and if it's just the way that this particular system works. But otherwise, it does at least seem to be able to synchronize the R clock, and it may even be that it is a synchronization problem that's thrown it completely out, and that's why it can't read the data. But at least it's doing something, and it is controlling the clock phase. This of course has nothing to do with the firmware in the ROM, but I wanted to check this first just to make sure I'm not missing something obvious. So what I'm going to do now to make sure that this isn't an issue with the actual physical drives is I'm going to swap out the physical drive with the emulator and see if we get the same thing. Okay, I've swapped out the floppy drive for the Gotek emulator. It's all hooked up, ready to go, and I'll now run the same test as previously. I'll start the MIMI trying to read the drive, and then I'll rearm the analyzer and see if we can capture any raw data coming from the emulator. And indeed we can get some data. So we can see the bottom trace is the raw data coming from the drive, and the next one up is the R clock, and you can see they are perfectly synchronized. The emulator is going to be more accurate than the physical drive, of course, because it's not mechanical in nature, and so the VCO can lock in much more accurately on it. It is looking more and more like this may be a problem with the data slicer. That's the WD1691V. Everything else seems to be working. We're getting data. Now the possibility is of course that what we're getting is nothing more than the clock coming from the drive, but that seems unlikely because, as I say, both the emulator and the mechanical drive are doing the same thing. But when I press the B key, what I see on the scope is the frequency of the R clock is going to exactly 2 megahertz, which is exactly what it's supposed to be. And as far as I can tell, it's doing the same thing with what we believe are valid boot images for both the emulator and the mechanical floppy drive. So it is looking more and more like there's an issue within the data slicer I see, or some of the glue logic that controls it. What I'll do in the next video is we'll start tracing through the boot monitor code that's in the MIMI ROM. So I'll do that in the next video. In the meantime, anyone that's seen this fault or has any information on the MIMI, it would be much appreciated.